at least more than 50% of the people could not do the static of this problem. And I'm surprised there. Why you guys have any problem with the static? There is an object, bended, there is a load at the end. The slope is 3, 4, 5, so vertical component is 3/5. Some people have problem even with that. They put 4/5 on the vertical, 3/5 on the horizontal. Why? What is the big deal about it? As an engineer, can you make that kind of mistake? Of course not. This is the action there. So by the way, what is this? Notice I did not call this one P. This is what this is this. This is chapter 1. Chapter 1, which is sigma equal to P over A, as you saw it in ME 218, actually is N over A. What is N? N is normal force. Yes or no? Is that correct or not? So there is a normal force. For some of you, which I had time, I wrote it. This is the subject you learn in chapter 1. Yes or no? Sigma all over this cross section. P sigma equal to N over A. It is in the way it's drawn or the way the force is given. This seems to be in tension. Yes or no? What is this force? Notice I changed that. Some of you are still writing Fx, Fy. And interesting part is this. I give you something like that. I don't understand this part of it. I give you a force here, P, and you want to find forces here. And you write here, one person wrote R cross product. Few people have to write sigma Fx, sigma Fy, and this and that. Why? There is one vertical force here and one vertical force here must be equal, and what's the big deal about it? I don't understand, you guys. See, when I don't see something that I do not understand, I want to find where is that coming from? Why you cannot see that so simply? There are one vertical force, one horizontal. Look, this is all I'm saying that. This, divide that into two components. Yes or no? Yes, that component is 3/5 of P. This is 4/5 of P. Is that correct or not? That transfers here or transfers to the lower part, upper part and the lower part. Upper part will be equal and opposite on the lower part become opposite to that. Some people put all mixed. When you see that, that automatically gives you this and this and a moment. But I don't know which moment because this moment and this moment goes clockwise, that moment goes counterclockwise. Everybody see what I'm talking about? That is the static of the problem. If you have problem there, whatever you put afterward is not going to work. Is that correct or not? That's why I was a little bit surprised, a little bit shocked. But nevertheless, this is the static of the problem. In this direction, you have this much moment because notice this one is larger distance and larger force. So obviously this moment is larger than that moment. Yes or no? This is shortest distance, smaller force. This is larger distance, a larger force, and larger distance. Therefore, this item bends this way, not this way. Is that correct or not? Yes? Everybody agree? Because this way action is larger. And that's that action. So I showed it in that way. So you have this much M. You have that much shear force. You should not show that at Fx, Fy. What are you talking about Fx, Fy? They call this Fx. Some of you call this Fy. That is a normal force acting on this section. Yes or no? Which is sigma actually. Sigma equal to N over A. That's what the understanding comes from. When you start writing this force as Fy, I don't know even what you are talking about. Fy is for static classes. You have gone through all the strength of material classes. We are not talking about. We are talking about shear force, chapter 6. Is that correct or not? Normal force, chapter 1. Yes or no? Moment, where did we study the moment? In chapter 4 and 5, chapter 4. Is that correct in the new book? Is that correct? Chapter 5, all was about moment diagram and shear diagram. Look what we are at. We are much more advanced than that one. Everybody understand that? And half a class couldn't get this. Surprising. Yes or no? I hope that is just an overlook. Is that correct or not? Yes? Now we come to the stress. Where is the point? Now, look at the moment. At this point, and this point, and this point, and that point doesn't make any difference for N. N everywhere is uniformly distributed. Stress equal to N over A. Is it tension or compression? It is tension. So you put sigma H, so N over A, because H is here. Now look at H is not at this point. This is A, This is B. A is at this end. According to here, this is tension side. This is compression side. Everybody see what I'm talking about? Everything measured from the centroid of neutral axis. That's another question that's very, very bothersome. So this is the section. Yes or no? Yes? This is point H. This is C. Many people say, where is neutral axis? Which way this column is bending? Is it bending this way or is it bending this way? So what, isn't that this should be in the neutral axis? How come, again, another half class or 60% of class take the other side as the neutral axis? Why do you calculate I about this axis? Is it bending this way or bending this way? You all said bend that way. Yes or no? Anyhow, this sort of thing, I would not buy it if you have gone through ME 218. This is your neutral axis because your moment is like that. Is that correct or not? What all I'm saying that you have this force, which gives you uniform stress, this bending, which this side is in tension, this side should be in compression, yes or no? So sigma H is plus N over A minus M not C. C is at A and at B. What should I put here? M, Y, the distance from? No, not A. Some people make that mistake again. Many people do that. It's taken from the neutral center of neutral axis. Everything in bending, everything is measured from neutral axis. You see, this is what you learn in typical problem. Everybody has gone through that. Is that correct or not? When you say this is tension, this is compression, you say always this is maximum tension and this is MC over I is for top and bottom. If you are here, that is not, this should be Y. Maximum Y is C. I cannot go through ME 218 and give you all of that. This is something you are supposed to know. Yes or no? Yes? The only thing is this, instead of being vertically like that, I changed it to that. That's all I did. Is that correct or not? Yes? There is nothing new there. Therefore, look how many mistakes you made. That is Y. What is the Y now? This is the Y. So this was 18 millimeter. Half of that is 9 millimeter. This is 5 millimeter. So Y is equal to how much? Y is equal to 4 millimeters. So there is. And I, look at the I. Area, you need the area. Area is 12 by 18 anyhow. So 12 by 18, write it down. You want to write it. That is equal to 216 millimeter square, or equal to 216 times 10 to the power of minus 6 meter square. Minus 6. Many people use minus 3. This is millimeter square, so you use that. The I, this problem for the other class, actually I was IB. This is much simpler. I was 1/12 of base, but what is the base? This is the base, this is the height, because this is the neutral axis. Yes or no? You are bending it from that side, not that side. Is that correct or not? Yes? So 1/12 of 12 times 18 to the power of 3, which ends up in millimeter to the power of 3, or it becomes equal to 5.83 times 10 to the power of minus 9 meter to the power. Remember, I always said use minus 6, minus 9, minus 3, or plus. Never use 4, 7, 8, and 5. That's what you saw in yours. So because that throws everything off, because all our tables are on that basis. Nevertheless, everybody understand what I'm talking about? Yes or no? Now, everybody knows now the sigma, because now if I put my gauge here, or here, or here, or here, I read different result. Is that correct or not? My gauge was at this point. That's why you are finding the stress at that point. Yes or no? And the stress at that point, right now at point H, now I ask you to plot it. Come on, guys, give me a break. How many people put here forces there? They put 4/5 of P here, 3/5 of P there. That's out of this class, out of static class. We are talking about a state of stress, which is this and which is that. Is that correct or not? That's chapter 4, that's chapter 6. Is that correct or not? Didn't I give you in your homework problem from chapter 4 or chapter 6? Yes or no? Did you do it? So what's the problem here? Is that correct or not? You need to calculate the normal stress. We already calculated the normal. This depends which one. It seems to be negative. That's the problem that I purposely put there. So when you calculate this one, so let's see what we get there. We get to that point in a minute. So we get here n over a, n equal to what? N equal to 0.6p divided by area, which is 216 times 10 to the power of 6, minus m. M is equal to, you don't have to go. This minus because it is in the compression side. This and that. This is in compression side. This is in compression side. You don't. Some people put, I don't know. Some people put the minus here, then a minus here. I don't know what we are really doing that. The direction of the moment here. This side of the centroid is compression. This side is tension. It's obvious. Is that correct or not? Yes. Therefore, it's the compression, and magnitude of m is 0.025p, or if it was p was given, you put a number there. And the distance from the C, which is at that point H, is 0.004 meter or 4 millimeter, divided by I. Of course, the I have to calculate that. I give it to you here, 5.83 times 10 to the power of minus 9, sorry. I said 9, but I wrote 6. So that must be equal to the sigma, right? But the sigma was how much? Sigma is epsilon times. No, this is epsilon. I don't know. You see, I want you to learn something new for future. I put a P there symbolically, but when I read the strain gauge said, is it plus or minus? Plus. So every one of you calculates sigma at that point. Unfortunately, that one was done correctly because I did example in the equal to epsilon times E. Is that correct or not? But when you do that, sigma end up equal to how much? Many of you did it correctly. Some of you had problem with that. Becomes 71.8 times 10 to the power of 6 Pascal, which is Newton per meter square. So you put that one here, and you solve for P. Is that correct or not? If you do it correctly according to the right, many mistake here in this, many mistake in this one, in this one, in this one, in that one, everything. Everybody see that. So you can see how many mistakes you made or not. Is that correct or not? When you calculate that, unfortunately, P ends up, or purposely P ends up as a negative number. So it ends up to minus, and nobody paid attention to that. Actually, if you do it correctly, it ends up to minus, very close to 5,000. It becomes 4,996. My intention was to round it off. If you go one more digit, it ends up to exactly 5,000 near you. That means the force is not going in that direction. The force going in this direction. Yes or no? Now, why I'm trying to tell you this? Because in a week or two time, we are going to discuss that. In future, you know what happened when there is an accident, airplane accident and the car accident, and then when they want to look at all the part, they don't let anybody go close to the accident site, because people, engineer, especially engineer, mechanical engineer, and civil engineer, they want to go there, they want to take a picture of all the cracks. Is that correct or not? And those direction of the crack, which is direction of principal stresses and maximum shear, will tell them two things. One, whether this is the shear crack or it is a tension or compression. And certain, then you can backtrack to see what kind of forces causes that kind of damage. So you don't know the force. So they know a force is coming, but there were some gauges when you're flying with the airplane. When we get to the strain gauges, which is in 2 weeks' time, I will explain all of that. When you fly in the airplane, there are 10,000 or even more gauges all over the place. The captain doesn't know anything about sigma and tau. You know it. Is that correct or not? If something goes wrong in one department, or it's a little bit extra heat or a little bit of crack appear, let's say somewhere, the gauge next to it is going to show extra stress. Everybody understand? The extra stress becomes extra strain. Then immediately the red light goes on. Everybody understand that? That is what we want to find out, what kind of forces causes that kind of deformation. And that's exactly like that. Reading it like that, show me the P should not be that way. The P should be that way. Is that correct? Because the answer came negative. Everybody understand that? Because if this is stress is minus 17.1.5, my reading should have not been positive. It should have been negative. Everybody understand what I'm saying? That is that understood? Yes or no? because for that reason, you end up with minus P. So this is your value of the P. This is the answer I was looking for, going that way. Is that correct or not? Yes? The state of stress at that point now, all this direction changes. Notice because of that, now actually you have this, you have that, and you have that. Is that correct or not? This is the actual load. Now you know exactly what's happening there. So at this point, I asked you to draw the state of stress. Now, a state of stress is consistent. Look how much calculation I did. Only this. Remember, you need A, you need I, you need a static, and put this number together. And now we're calculating the tau. So anyhow, actually, you don't have to do anything here. It's the funny part. State of stress at that point, let me erase this one because I put the word there. At point H, what's this stress now? That's already given to you. Half of people, when they recalculate that stress already given to you to be 71.8. Why do you calculate that? Because the understanding is not there. Is that correct or not? So when I ask you to do part 2, part B, actually you already half of the answer is there. Is that correct or not? That's the state of it. What you need to calculate only, I was checking to see whether you can use the other equation, which requires now calculating this shear, because they're actually going that way. Is that correct or not? So it's going that way or this way and that way or that way. And this is the state of stress. This is already given to you, part A. All I'm asking you to calculate tau. Actually, I was written in here, but I ran out of room. Is that correct or not? The tau equal to what? VQ over IT. Where are you? Now, here is what we discussed before. You need Q of that, yes or no? Because H is here. Is that correct or not? Yes? The shear stress going, the shear force going like that, that's your shear first. The shear stress going like that, which you can see it, I put it that way on the top. On the bottom goes like that, etc., etc. The only question is, shear force is 3,000 or 4,000. Because it was 4/5 of, remember it was, go back again. The shear force was 4/5 of P, yes or no? If P is 5,000, 4/5 of 5,000, so it becomes 4,000. So that's your shear force. I already was given, this is the I. The T is what? The T is, the T is this length, which is 12, yes or no? T is 0.012 meter, correct? The only thing that actually you have to calculate here, that's what the only thing question was really, is the value of Q, which is Q of this area with respect to neutral axis. This is 12, this is 5, yes or no? The Q, this is what I was looking for. Q equal, actually some of you did it. 12 times 5 times this distance. Is that correct or not? You put that mass here and that distance, of course, this is 4.5 of pi is 2.5 is time 6.5, and this will be in millimeters to the power of 3. Yes or no? Area times distance. Correct? I think you did your Q correct. Correct? I don't see anything in this problem that you haven't heard it in ME 218. Why so low quiz? So for that reason, I decided earlier for the other class to continue with some example of the Mohr circle. I should be right now on the as I said, I had prepared this originally for today's lecture to go through the pressure vessel, but there is no sense to go through the pressure vessels and design of the beam and shaft and then go to the gauges, the strain gauges and all the new thing without understanding the nature of Mohr circle and what's happening. Everybody understand. For that reason, I'm going to do a couple of problems quickly. First of all, everybody understood that one. I want to go over that. I explained it last time. Everybody can see what happened here. Whenever you calculate, you go with the X and Y, which is usually like this. Is that correct or not? Then you go to the principal stresses, which either goes counterclockwise or goes clockwise. But one thing important, I may not have mentioned it, with that you are interested in that. You are interested in the principal stress, not the original stress. Is that correct or not? Because principal stress is the maximum. Now, here they are showing the principal stresses, not the original stress. So as you see, let's put it this way. This is your original state of stress, yes or no? Then let's say you go like this for your principal stresses. Principal stresses, this is principal 1, this is principal 2, and this is principal 3. This is x, this is y, and that is z. Notice the direction of the z never changes when you do that. This rotation is about what? Last time we discussed it. This rotation is about the z-axis. That's why this value never changed. P3 and z are the same. This is axis. So you're going like this. As I showed you last time, this rotation this is the review of what we did last time. This is your xy cubic. I didn't bring my cubic there. You go like that. That's your principal, no shear. Everybody understand that. Now, what they are showing here is this, but assume you take this board and turn it around. Everybody understand? Because this is the key, not the other one. Yes? This is principal stress. Yes or no? This is associated with the x-axis. This is associated with the y-axis. They showed you the type of stress you get for the shaft and beam. Always one happen positive, one happen negative. This is always typical. You didn't know that, but that's what was going to happen. Therefore, this is when you draw the circle become like this. The circle become one like that, because sigma principal 1 is positive, sigma principal 2 is negative. Everybody understand that? Since sigma c is here, so you don't have to worry about it. That's why we went through the design in the ME218 without even mentioning any of this. Everybody understand that? Therefore, the other two circles become inside. So tau max, which is maximum, is equal to R. But what rotation should I do that? Because this is principal 1, principal 2, and these two are at 90 degrees here. On the original axis are at 45. So that's what you see. If this is principal plane, this will be, look at this. Look at my hand. It goes 45 degrees. That must be the direction of the shear. But look at my thumb. Is my thumb moving? So that's the rotation about the x, which is your original solid circle. Yes or no? Yes. However, this is not always the case. You cannot understand this. You must, let's put it this way, you must understand this until I tell you the stresses in the pressure vessel, because pressure vessels are not like that. The pressure vessels are both positive. Everybody understand that. If they are both positive, so if I get a sigma 1, principal 1 here, a sigma principal 2 here, this is my solid circle. Yes or no? Both positive. As you see here, there is somewhere should be both positive. Is that correct or not? 40 and 20. Is that correct or not? Now, there is an R here. We are not arguing. That R is there. But that's not the highest value. You see, because this is only circle about the x and y. You see, assume this is x, this is y, or x prime. These are all the x prime, y prime. Everybody understands. Those are all the x and y and x prime, y prime. Yes or no? Correct? Because when you draw the circle, you're just moving it around. Yes or no? So they are moving about, this is the circle about the rotation about the z-axis, and this rotation is about the, as you see, is about the y-axis. As you see it rotating like that. Yes, so that means this. So if this is the x and this is the y, and this is the z or c, therefore this circle is not important, that circle is important. Why? Now, what is the principle? What is the maximum shear? The maximum shear is this larger circle. But the circle is between what? X and z, so the rotation must be about the y-axis. It is in that plane, which is there somewhere going like this. Is that correct or not? Yes? And the value of that is important. The value of that is not this circle that first you is the radius of this larger circle, which I gave you to you. Sigma tau max must be equal to 1/2 of sigma max minus sigma minimum. But sigma minimum, this is sigma P1, so it becomes 1/2 of sigma P1 minus 0, because this one is 0. So I said use sigma 1/2 of sigma A. Is that correct or not? Did you get it? And then there is a possibility that both be negative, so you get the other one. As you see here, one is positive, one is negative. So here, look at negative and negative. Everybody understand what I'm saying there? Yes? So about that. So look at that. Now, for that reason, I'm going to do one more problem that is similar also to your homework. Okay, we don't need that anymore, so let's put the board, that one up. So let me take this out. Now, what I do suggest for you to do, I forgot to mention it here. If you want to do problem number 1 and 2 right, correct? Go to your handout, the first handout. There are 4 pages between page 14 to page 18. I did one problem in totality. You are still talking about, yes, look at this problem. This is summary of everything that we talk about in ME 218 and ME 219 so far. There is a shaft here. This is, now what you can do to it, when you look at it, all the results are there. Is that correct or not? If I were you and I have any question, the intention is to find the state of stress at point A, B, C, and D. And all the detail of it is shown there, and at the end is a state of stress. Try point A for yourself, and you get all the number, do it yourself. Anytime you make a mistake, go back and check your mistake, but do it yourself. Everybody understand what I'm saying? Do not look at it and tell yourself that, oh, I can do that. The whole problem is to be able to do that. Everybody understand what I'm saying that. So please, so therefore, that is a good example for you to follow all the way. So do that. Now, this is another example that I want to do. Okay. Here is something similar to one of your homework. Please write it down. This is not in your handout. This is a state of stress given to you.
5 megapascal inside for each.
Yeah, 5. This is 5, this is 5, so both are 5. Did I put 5? Yes, 5. 20 positive, 10 positive, 5 positive. What was the question?
No, I was just making sure that was right.
5 megapascal. Let me take a glass of water. When I get too excited, I run out of edge, especially the last class, so I have to cool off a little bit. Sorry, guys. All right. Now, this is a state of stress. We did it for some kind of loading, as you saw we discussing it. Then suddenly somebody else come and said, another fellow in your firm, I said they took the same object and this time did some testing or some other way of calculating, let's say, the stresses due to temperature or some other reason, and find out for the same point, this is the same point, exactly the same point, find out another state of stress due to another type of loading, and it comes out that the state of stress there is equal to, at the same point, oops, that's the wrong way, no, that's correct. So this is 30 megapascal, and this is 10 megapascal. No shear. And that angle is given 30 degrees. You do two design for the same structure, for the same point. These are the stresses. Now you want to put the structure under the both stress. Is that correct or not? You understand what I'm saying? That as a result, you need to add these two together. Can you add them together? Not in this form. Everybody understand what I'm saying? That because one is about this XY axis. The other one is about this XY axis. Yes or no? Which are different from it. Obviously, one solution that somebody suggested from the other class, can we break that into component along X and Y and add it together? If they were forces, yes, you can. But these are stresses. This is depend on the I, depend A, as you understand, and from point to point, this keeps changing. No, you cannot do that. Everybody understand that, yes? The forces, always you can do that. The force has nothing to do with the area. Then you use that resultant force. Is that correct? But these are not forces. These are stresses. Therefore, all I can do, turn one of them to become like the other ones. For this problem, it is obviously I keep this one, and I turn this one, how many degree? 30 degree to make it equal to that. Then they are in the same direction. Then I can add it together. Yes or no? Notice this is the application of the Morse circle. Yes or no? Of course, you can use the equation. How much transformation do we have? We have transformation of theta equal to 30 degree plus. Is that correct? Because you are going counterclockwise. Everybody with me? Yes? You must transform this way. Yes or no? So let's do it with the Morse circle. Correct? The idea is this. If you are solving this problem, which is similar to one of your homework, you have to turn one of them to become equal to the other one. I could keep this one and turn this 30 degree. Everybody understand that? Then I have to deal it this way. Yes or no? Correct? So let's now do this one. Yes? Okay, because this is simpler. So if I want to do the Morse circle for that one, this is sigma, and this is tau, and that's the arrow. Remember? This direction, we call it positive, and this direction, we call it negative. Correct? You can take that chair if you want. But you need the rest of your stuff too. All right? Is that correct or not? Yes? All right. Now, how do we do that? Now, this is your x. This is your y. Forget about that. This would become your x prime, and this become your actually, x prime, y prime become parallel to this. Is that correct or not? Yes? So where is x? How much stress do we have on this surface? Is 30 and what? 30 and 0. Very good. Everybody understand that? Yes? Because this is principal stress after all. Yes or no? Principal stress should be on this one. Yes? And the other side we have minus 10 and 0. And this will be your circle. So, correct? But don't forget, this is x, this is y. Where is sigma average? Notice this distance from here to here is 40. Yes or no? The average of that is 20. So the radius is 20. Yes or no? 20 megapascal. Yes or no? You don't need any formula. OC, this is the center, is equal to 10. 10 and 10, 20, and that's 20. Yes or no? So OC is equal to 10 megapascal. Correct? Which is sigma average. Correct? Yes? Now, what should I do? I have to take x and y, go 60 degree counterclockwise. Very good. This is x and y. I have to go 60 degree, so it ends up like that. So this becomes x prime. Y prime is almost there. Let's check that to see where it is. Is that correct? Yeah. What do we need? We need this length, OH. That is sigma x prime. Yes or no? Correct? OH sigma x prime. So OH equal to sigma x prime equal to what? That's what we did last time for you. Is equal to, what's OC equal to? OC equal to 10. So 10. This is a very simple problem. Plus, what's the radius? The radius is 20. This angle is not 30 degree. That angle is, you all agree, is 60 degree, correct? So plus what? Plus CH, which is R times cosine of 60 degree. Yes or no? Okay, plus R, which is 20 times cosine 60 degree, which is 0.5. So that becomes 10 plus 10 becomes 20 megapascal. Correct? Then what is sigma y prime? This is sigma y prime. So you don't have to calculate that. Actually, it's negative. So you come forward, then you subtract the same amount. Because this length and this length, if you draw in a scale, should be the same. Because it's symmetrical triangle. Yes or no? Yes? So it is 10 minus 20 times cosine of 60 degree become 10, become 0 actually. Correct? That's why sigma y prime become on the y tau axis, correct? Now, what's tau x prime y prime in magnitude? Tau x prime is equal to 20 times sine. Is that correct or not? Yes? Which is 0.866, so it gives 17.32 megapascal. Yes? Is it plus or minus?
It's minus.
It's minus. Is that correct or not? Everybody agree? Why? Very good. So if this is x prime and y prime, which we went this way, for example, from here we went to there. On the x prime, it is plus, so it must be going like that. Is that correct? What plus? That's not plus, that's minus. It should be going like that. Is that correct or not? Because I should go parallel to this. Yes or no? On here is parallel, so I should go that way. So I went that way. On the y prime is negative, so I should go this way. Is that correct or not? Yeah? So therefore, this will be like that, and this is a minus. Is that correct or not? So absolutely right. This ends up to be minus. That's something you have to determine.
Can you repeat that? Can you explain it one more time?
What?
Could you explain one more time why it was negative?
Do you understand this one first? Yes or no? Be frank. Yeah? See, when we draw it like that, look at this one. Tell me, what did I write here? Is this plus or minus for our sign convention? Positive, correct? But Mr. Moore did not draw it like that. Mr. Moore, when opened this up like that, he saw this arrow going this way, that arrow going this way. They are going in opposite directions. So he gave one of them a positive sign, which one of them are negative sign. Which one is positive here? Don't look there. Which one is positive here? You see, he said anything going this way, call it positive. Anything going that way, call it negative. So what is this? Plus for Mr. Moore, for the Moore circle. This one is the opposite to that. So that one become negative. So that's a positive case. Is that correct or not? Yeah. For the negative case, look, this is going that way, he called it positive. Or this is going that way, he called this negative. Look at here. On the x prime, is this x prime axis? Yes or no? And this is y prime. On the x prime, what do you show here? Are you showing here positive above the line or below the line? Is this plus or minus? Don't look there. It's here. It is. Look, doesn't matter sigma or tau. When we draw x and y, this y is positive, that y is. That's the fact. Yes or no? So what I'm saying that change that to tau. Anything here would be positive. Anything here would be negative. What positive means this way, negative means that way. Yes or no? Correct? Okay. So on the top, x prime is what? Positive. Yes. So how should I draw it? Downward or upward? Yes? I lost you? You got it? Okay. So I draw it like that. So I draw this one positive and I draw that one negative. But then eventually when I do that, because I change it going in, I change it, I coming out, I change it, the two changes cancel each other, I should back to the normal. Is this a positive shear stress or negative shear stress? See, if the other one is positive, this should be negative. That's what I did. So therefore, I put there minus 17. Correct? All right. If you see me a little bit slowing down, it's something happened in me. I just want to be a little bit careful. So when I was talking, have to relax a little bit, couple of minutes. For my age, I should not get that excited as I did. Is that correct? I need to get another glass of water. You can turn off the camera for time being. You don't want me to have heart attack here in class, do you? But you know how passionate I am about teaching you guys, and you have to cooperate. When you don't cooperate, it makes my weekend miserable. You understand what I'm talking about? Then I get into this scenario because I always feel that you should do 100% better of what you are doing, and that's why I'm explaining all of that. Is that correct or not? I hope you understand me. I hope you start working, because usually all my ME29 classes are very lovely, and everybody participates, everybody knows what they are doing, and because we understand each other much better. Everybody understand what I'm saying that. So please start sort of working with me. Anyhow, so what happened here at the end is this one. So we don't need that anymore. So what happened here is this changed now. This changed to what? This changed to this state of stress now. Here is now x prime, and this is the y prime. Yes or no? What is the stress in the x prime direction? You calculate the value. The value is 20. That's right. So this is 20, 20. What's the value in the y prime direction? 0. What's the shear? Negative. This is the negative shear stress. Is that correct or not? And that value is 17.32. Now I can add these two together. This plus this become the new state of stress of two operations, two system of loading, maybe one system plus the other one. Is that correct or not? Yes? Yes? That was the same point. We designed it for two different way of loading. One was like that, but I turn it, make it parallel to each other. Now these are can be added together. Here I have 20, here I have 20. The net result here is 40. Here is 10 plus 0. What's the net result there? 10. Correct? How much shear do we have? Now you can answer that question now that this is positive 5. This is, in other words, this is going this way, that going that way. You don't have to worry about positive. So what's the net result is? 12.32 going negative. That's right. So if somebody asks you what's the summation of these two stresses, summation of these stresses, now sigma x equal to 40 megapascal, sigma y is 10 megapascal, tau xy is equal to minus 12.32 megapascal. Is that correct or not? Do you have that in your homework? Yes?
Is the shear stress on the left side of the...
It's positive. Which one?
The shear stress
Oh,
on the
you have it drawn.
No, that minus and plus is for the Morse circle.
No, on the...
That's you have it drawn on the left side.
This is?
Negative, and then on the...
Oh, this one. Oh, I see. Oh, I see. This arrow is wrong. Correct. It's going up. This must be going down. Is that what you're saying?
Yeah.
Okay. No. Okay? All right. Now, what do we do about that? Now, the next question is what we were talking about, I was showing you earlier. Find the principal stresses and absolute maximum shear. Yes? Okay, let's do it. How do we do that? See, little by little, you get hang of everything, then you understand what's going on here. So therefore, this time, I'm going to put all the numbers here. What's sigma average? You can do it this way, or let's do it with the Morse circle again. So let's do it with the graphical. Sigma versus tau. Again, this arrow comes down. Again, you know the meaning of arrow. Yes? Okay. What are the stresses here? See, that's the question you guys do, the one you asked me that question about the sign, that you can answer it yourself here. What's the sigma equal to? Sigma equal to plus 40. So you go 40. And what's the shear value? No, the whole shear there is negative as far as we are. The only problem is, should I go up or should I go down? Up, because it is following this arrow, yes or no? If it is parallel to that, arrow must be plus. Is that correct? So I must be going up. So I go up here, 13 or 12.32. 3. Is that correct? Yeah. Now, what about the other side? The other side, I have plus 10. Is that correct or not? As far as the sigma is concerned. As far as the shear is concerned, I have, you don't have to worry about it. If this is plus, this was minus. It's always the typical of Mohr circuit. If one is plus, the other one must be minus. Because otherwise, it would be like that. It opens up. Is that correct or not? That's the reason. So he always gets 1 plus, 1 minus. Is that correct or not? So doing that, I should be going down. So that's your x. Of course, this is, let's say, x has the coordinate of 40 and 12.3. Y has the coordinate of 10 and minus 12.3. That's all. Then you connect these two together. What's this one? This one is the center of the circle. Yes or no? Yes? So what's this length? You see, it's all sitting here. You don't need anything. You only need this triangle or the other triangle. Everybody understand that. Now, what is this length OC? Notice this is 10, this is 40, so 10 to 40, that's 30. Yes or no? Half of that is 15. So this is 15, and this is 12.3. Yes or no? Yes, look how simple that is. Correct? So can you calculate R? R equal to, R is here. Is that correct? Is that R? Because this is on the circle. So this is the center of the circle. This is on the circle because this looks like a diameter of the circle. So this is the R. R equal to, you do not need any equation. 15 square plus 12.3 square. By the way, equation-wise, that's a sigma x minus sigma y divided by 2 square plus tau. Who cares? It's there. Yes or no? Yeah. So equal to, get the number. Let me give you the number. The number is, here the number is, what did you calculate? 19.4. So let's put 19.4 megapascal. Sigma average or OC, sigma average, which is the same as OC, of course, is 10 plus 15. It is 25. You don't have to even calculate that. It's there. Then you draw your circle, which is somewhere like this. Is that, but it has to go through all this point. You have to go like this. You know, I cannot draw that. Is that everybody understand that this should be there somewhere, if it is in? Correct? Something like that. Is that correct or not? Yes. So this will be point A, and this will be point B. So if somebody asks you, you can calculate that. Sigma A equal to 25 plus 19.4, which is 44.4. And sigma B, which is 25 minus 94, equal to 5.5, 5.6 or 5 megapascal. Correct? Now, here is the discussion we have last time. What's maximum shear here? We don't call it maximum shear. From now on, we call it absolute maximum shear. You see what absolute means? It means you have to look at all the 3 circles, not one circle. The way we learn it in ME 218, we call R equal to tau max. Yes or no? Which plane is that? That is XY plane. Is that's the rotation about the z-axis, yes, sir, which is at 45 degrees from A and B. Because look, C and D are at, here is 90 degrees, or the real problem is at 45 degrees. Yes or no? That's why I turn it 40. Remember that color picture that I show you? Yes or no? Yes. So we call this one, which is equal to 19.4 megapascal. We call this one in-plane shear. In-plane shear. Why? Because our state of stress, this is one more time explaining it, is rotating like that. Everybody understand? It's not coming off this plane. It still is in the plane because the rotation, you said, is about the z-axis. Yes or no? But is this really the maximum shear up there, or there is another shear there? There is 2 more shear, and I have to look at that one. Those are the rotation about the y-axis and the rotation about the x. But you don't have to worry about it. Already, since we know the significance of that one, all I have, this one is a circle between A and B, which is x and y. Everybody see that? This is y and Z, that is X and Z. That's as simple as that. So when you draw the two circle or three circle, one of them become the largest one. For this problem, the one become largest is X and Z. So the rotation is about which one? Is about the y-axis. But what is tau this time? Tau max is still sitting here. Use that one. Tau max, which is in which plane now? This is very important. It's not in the xy plane. It is in xz plane, because you said it's rotation about the y-axis. Xz plane is equal to 1/2 of sigma max minus sigma minimum. What is sigma max? Sigma max is A, sigma minimum is 0. Yes or no? Correct? Yes? So therefore become 1/2 of 44.4 minus 0 or equal to 22.2. As you see, it's a little bit larger than what we have before. But this we call it out of plane shear. Why is out of plane shear? Because we had, you said rotation about the y-axis. Yes or no? You see that, the direction of that? So if this is principal stresses, you end up like this. You see that? That is where you saw those color picture. Yes? It is in your handout. You can take a look there. So one rotation is about the x-axis, one is about z-axis, one rotation is about x-axis, one rotation is about the y-axis. For this one, you just, all you need that. But what you put in the design criteria, this is it. You don't put, look what is important here. You don't put 12.32. This is where you calculated it, yes? This is the original circle, yes? Now you come out with 3 circle idea. Is that correct or not? So you show you all the shear that is possible to happen there, because shear could be in any plane. This way, everybody understand that. Yes or no? So that is your absolute maximum shear for this problem. Now, did I do this problem for you at the beginning, at the end of the class? Did I give you the sigma different from 0? Did I do any example last time? I remember I did not do. So I rather than do that problem first. Now there is another problem, again, similar to your homework. So please write this one down. This is not your homework. I'm not doing your homework. I'm doing this similar to your homework. Guys, please pay attention. We are short of time, so we want to do that. Let's say that we have sigma y is given equal to 30 megapascal, sigma z equal to 100 megapascal, and tau xy is given equal to 84 megapascal. And I want you to do 3 problems here. 3 problems into one. Do it for sigma x equal to 0, sigma x equal to minus 60 megapascal, sigma x equal to plus 60 megapascal. I'm going to explain the significance of all these 3. And this is the standard. Now, what is the standard? Means that's what you were always doing. Okay, what we are saying is this. Exactly what we did it here, there. So they accept it, the planes has changed. So our plane is not in the xy plane. Your plane is z. So it doesn't matter. You are designing here or there or there. Everybody understand that. So that does not change the problem. This, if you want to translate it in the state of stress, this is your state of stress. Yes or no? With the cubic there, whether you put cubic or that way. So sigma x equal to how much? I mean, there is not. Actually, this is y and z. Sigma y is 30 megapascal. Correct or not? Yes. Sigma z is actually 100. So be it. 100 megapascal. Correct or not? Yes. And tau xy is positive. Again, somebody asked me, what is positive? Positive according to us, not according to the Mohr circle. Everybody understand that. The positive means what? This should be going up and this should go that way. Is that correct or not?
It wouldn't be on the side, because it's X, Y number.
Oh, no, that's wrong. That should be YZ. Sorry, I made a mistake. Because always we call it XY, so how can it be? It is in the YZ. So we are calculating everything in the YZ plane according to what we did. We cannot jump around. That way. Is that correct or not? But however, look, sigma x equal to, isn't that what plane stress is all about? Yes or no? Sigma x equal to, isn't that the same problem we did here? Yes? But we just changed x to y. I mean, we call x y, y z, and z x. Everybody understand what I did? That should not change the nature of the problem. Yes or no? This is the standard problem, this problem, that problem, and I want you to calculate the absolute maximum shear. I don't want the principal stress, nothing else, because that we have already done it 10 times. Is that correct or not? Find absolute maximum shear for this problem. What do I need? I need only sigma A and sigma B, which is very simple to calculate. So let's calculate sigma A, which is let's calculate sigma average first. What's sigma average equal to? So your homework goes like this. Don't make it any fancier than what is required. Sigma average is 30 plus 100 divided by 2. So that's equal to 100 plus 30 divided by 2, or 65 megapascal. Is that correct or not? Yes? Then you calculate your R according to the equation or whatever you have there. Is that correct? You can draw a little circle if you want. I have it here. You can go by circle or you can go by equation. Doesn't matter anyway. So the equation is equal to sigma sigma y minus sigma z squared divided by 2 times tau xz yz. See, notice I always use the standard one, so I just go back to a standard. Yes or no? This is YZ plane. Is that correct or not? Yes? This is tau YZ, and that's sigma x, and this is sigma y. Sigma x, this is sigma y, which is 30 minus 100, 70 divided by 2, 35 squared plus 84 squared. So it becomes equal to, for your information, that becomes equal to 35 squared, which you can get it from the Mohr circle easier. And that is from 840 squared. So it becomes equal to 91 megapascal. And sigma A, or one of the principal stresses, which is sigma stress principal 1, it becomes sigma average plus R. So it is 65 plus 91, or it becomes equal to 156. Sigma B becomes sigma principal 2, sigma average 65 minus 91, or minus 26 megapascal. Correct? Yes? So what you are saying is this, my friend. This is sigma, this is tau. You don't care about all the principles. All you need is your 3 circle, yes or no? One circle is between 156 and minus. So that is your original circle, yes or no? 100, that's A and that's B, yes or no? Okay, so if the question is, standard question, what is sigma x? Sigma x equal to? Which is plane stress, remember that. So where is sigma A? This is A, this is B, or principal 1, principal 2, x prime, y prime. Where is the C? C is at middle. So I said last time, if the 2 are opposite sign, remember you wrote that one down. Is that correct or not? If the 2 have opposite sign, the other 2 circles become, you have to draw it, but it is insignificant. Is that correct? Right? That's what typical of shaft design and the beam design. You never noticed that, but all the problem you did in ME 218, they always end up one principal positive, one principal negative. So not because there were not 3 circles. We should not worry about it. Is that correct? Or because they are not significant. Yes or no? The same object, whatever you were designing, let's say this was a shaft and part of a machine, you put it now into a system that goes underwater, yes? And you go deep down 10 feet, 20 feet, or 30 feet, the further you go, the more stress you have. Let's say now this one, sigma x equal to how much? Negative 60 megapascal. You have a pressure coming now from from the x. Is that correct? I'm assuming the other one already been incorporated. Is that correct or not? So only I'm talking about the free surface. Is that correct or not? The one that is pressure coming. Is that correct or not? Yes? So what happened there? No. Notice this is no longer a plane stress scenario. Everybody understand that. So you don't have to worry about it. It's so simple. Yeah, you already have the home. You already have the answer. So what you are saying that my circle still is there. Is that correct or not? This is 156. This is minus 26. But this is principal 1. This is, or this is x. This is y, or all the associate. When I say x, y, y, I mean x, y plane and all the x prime, y prime. Everybody understand that? Yes? Because that circle is for, oh, in this case, no. Sorry. In this one is y and z. Is that correct or not? X, y is the standard. We use x, y, and z. Is that correct or not? Yes? Now, what is sigma x? In this one, sigma x was equal to 0. In this one, sigma x is negative where? Negative 60. So if this is y and that is z, everybody understand what I'm saying? That if that happened to case, then this is the circle and that is the circle. This time the circle is between y and x. Everybody understand, which is out of plane. But that's not the point. We don't care about that as much. We care about the largest circle because that's what we want it for design. And in the design, we don't care whether this tau is positive or negative. You then don't care about it. None of them become important. I'll show you that later on when we go to the shaft design. You will see that positive tau and negative tau will not have any effect in your design criteria. Everybody understand. We'll see that when we go next week. So what is important here, you want R of the larger circle, which is out of plane, is not in plane. Is that correct? Because in plane is y and z. Is that correct? And this original circles was the rotation about the x-axis because I changed the nature of that. However, here you are saying this is between y and x, so the rotation is about the z-axis. Is that correct or not? Therefore, what is the tau? That's what I want you to tell me. Tau max is equal to 1/2 of sigma max, which is 156, minus sigma minimum, which is minus 60, so automatically become plus. That's why they add to each other. Minus, you see there it's written there, minus sigma minimum, but sigma minimum is minus 60, yes?
Did you just shift over make it -60?
No, because this is given. You cannot see it from there. Sigma x for this was problem number 1, this is problem number 2, this is problem number 3. I said if you put it underwater, lock it water, the pressure become compression, yes or no? Versus the airplane. When airplane goes to a sky, outside of the plane, it's under, not compression, it's under tension because vacuum there. You see that one is tension, that's the third problem. So the same plane that on the ground, it is plane stress, when it goes in the sky, the body of the airplane is going to be stretched that way as well. Everybody understand what I'm saying that, yes? So therefore, for the second problem, this becomes 60 plus 156 divided by 2. So that becomes equal to, how much did we get? 108. So 108 megapascal out of plane. So it is out of plane because our original plane was YZ. This is not YZ certainly. Is that correct or not? Yes? This was the rotation about the Z-axis, or it was like that. Is that correct or not? Yes? And the value of that one. Now, the third option is I take this object instead of putting it under the ground, under the water, I'm sorry, which is on the ground is the same thing, taking it into where there is no pressure there. Is that correct or not? Yes? So that one, the body of airplane will be in tension. That's the third problem. How much did I give you this time? Or similar to that one, not exactly. It's just to show you what's going to happen. This is plus 60, yes or no? Now you do that one problem one more time. So you draw your original circle. This is 156, yes or no? This is minus 26. Now the third one is not 0. The plane stress was 0. When I assume it is 0, we call it plane stress. Yes or no? Yes? Now, therefore, it is 60. and then the other two circles become like that. Is that correct? Which become again insignificant, so the original circle still is the maximum shear. Yes or no? So the tau max is out of plane, original. No, in plane, I'm sorry, because the other two are out of it. So it's in plane, and the same value we got before, which was how much? 91 megapascal in plane, because these two are, usually we draw this in the, correct? Now, one thing I want to tell you is this. What we did here, which I didn't say it in the other class, is this. You have to learn this for future classes, this. When we have a stress here, a stress here, a stress here, all three of them. Let's say this is 100 megapascal or KSI, doesn't matter, 20 megapascal. This is 30 megapascal. It is one of this scenario. Everybody understand that. We have that principle, principle, and principle. Everybody understand. Now, if I put here a shear stress, and this is X and Y, notice I do not have the principle in X and Y, but I have principle in Z. Everybody see what that happened there. You have to be very careful about what we are talking about. Notice this is no longer principle. Why? Because you have shear. So you have to get rid of shear stress. How do you get rid of shear stress? By turning it around. Exactly. When you get to the principal stresses. Yes or no? But whenever you want to turn it around, you have to turn it around about the z-axis. But now it's still sigma z equal to 30. Now, what happened in graduate school is this. This is what we put under only pure, write it down, under pure tension or pure compression, like water pressure or vacuum. This is not really a 3D stress analysis. 3D stress analysis is very, very complex. You cannot do it now. Notice if I put here a shear here and a shear there and a shear there and a shear, this is the 3D. Now, I want to get rid of that one. I rotate that one. But as soon as I go back, this one always changes. This system doesn't work. Everybody understand what I'm saying there. This only works if this is only purely, this third one must be always a principal stress. Everybody, no shear there. This is a special problem. This is how we design it under pure water or under, because the uniform is everywhere. We don't have any shear. We don't have any shear going this way and that way. Everybody understand that. And we don't have any shear there. This still stays the same. We get rid of the shear by going through the Mohr circle. This could be 0 or could be minus something or plus something. That's it. That's all we can do. If you want to find it real 3D analysis, that is very complex. Everybody understands. You have to take 2, 3, 4 courses to be able to do that. Everybody understands that. You have to go through matrices. You have to go through some other system to get it done. Is that understood? Yes or no? Again, remember that. So this is all everything that you have to know about your homework. I mentioned it there. So please study everything and get ready.